RCHUB International Foundation for Research and Education, and ISO certified.
So we will end by 8:15. Okay. So let me try to recall what I have taught during the last session. So during the last session, we were speaking about what kind of analysis to be performed based on the different types of data. That is, we have discussed that when it comes to statistics, there are only two types of data. Either it could be metric or categorical data. So when it comes to statistics, there are only two types of statistics. One is descriptive statistics and inferential statistics. So in order to do inferential statistics, you should know that there are two types of data, metric and categorical. So categorical is nothing but the male and female, coffee and tea, what do you prefer? So this is what is the categorical data. Metric data is any data that deals with numbers on Likert scale based quotient. So what are the combination of these data? So if two data are categorical in nature, if two data, smoking, non-smoking, cancer patient, non-cancer patient, if two data are categorical in nature, then you will be trying to find out, is there any association between the two data or not, using chi-square test or correspondence analysis. Then coming to the relationship, if two data are metric, then you will be trying to identify whether there is significant relationship between the two variable or not using the correlation analysis. So say for example, India's GDP, once again, it's a metric data. India's population is a metric data. Relationship can be positive or negative, as I stated before. As the population increases, GDP decreases. So it is called as a negative relationship. In case if the GDP increases, the industry index also increases, which is a positive relationship. So if there is significant relationship, you can go for regression analysis. That is to find out, is there any significant impact of one variable on another variable? Or we can also say a significant influence of one variable on another variable or many variables. Then comes significance difference test. I told there are different types of t-test that can be used to identify the significance difference test. So let's start with an analysis. Let me share my entire screen, ma. Just hold on a minute because it may take some time for my SPSS to get loaded. So I tell you what this SPSS is all about. SPSS is a paid version of a software that used to perform various statistical tools related to social science studies as well as engineering studies. Mostly, many people in the engineering background avoid this SPSS and AMOS, thinking that it is a study package or it's a statistical package only for social science studies. No, it is not. It is capable of performing many statistical analysis, which the engineering background also requires. You no need to go for R language, which completely requires, there are various tools like Python or R to do some statistical analysis, but for which you require a program coding. Whereas this is completely different. By the click of the button, you may able to get the answers. So I'll give you some suggestions, ma. So is my entire screen visible? Just hold on a minute. Someone please tell me, is my entire screen visible, ma?
Yes, sir.
Okay. So if you don't have this application, there is a 30 days free trial for this SPSS, which you can directly go to the IBM website and download it. So try to download and use this software, or else your institution will be having this SPSS software. in a particular system, say in a management discipline or some other discipline areas, they will be having the license key. Try to use that system and try to perform an analysis. And even if you want a non-paid open source version, there is another thing, it is called as PSPP. That is exactly a replication of SPSS software, but exclusively made for Linux version. That is an open source software. And it is also available to download even in Windows version. You can also use that. The user interface and everything will be very much similar to this SPSS. So I don't have much time to teach all those aspects, so please don't mistake me. So if possible, if there is a separate class for SPSS, I will be teaching you each and everything at that point of time. Okay. So let me, where is that? Yeah. So what we have discussed? We have discussed that statistics can be segregated into two types. What are those? One is descriptive statistics. Another is inferential statistics. Let us start with descriptive statistics. I tell you what this descriptive statistics is all about. Very simple, Descriptive statistics is all about, just hold on a minute. Am I going too fast? No, right? Okay. Okay. Descriptive statistics can be segregated into following things, One is mean. The second is median, which will be using in most of the research. Then comes mode. Then comes kurtosis. Sorry. Then comes skewness. Then comes maximum value, minimum value. Then comes range. So all these things is nothing but descriptive statistics. This descriptive statistics says that what is mean? Mean is nothing but an average value, Mean is nothing but the average value. So for an example is the stocks. For example, if you consider TCS, the Tata Consultancy, TCS stock value, if it is over the period of, say, for example, for 10 days, it has been traded on an average at a price of 196 rupees. So we can say that the price value ranges from 192 to 205, but on an average, that is all the values 192, 198 for 10 days divided by 10, that is the average value. If you want to check the mileage of Honda Activa, the 10 Honda Activa, what you will do, you will check the mileage of each and every vehicle and divide by 10. So that is what mean value is, nothing but the average value. Median is the middle value. Okay, so for example, if you have 10 vehicles, instead of checking the mileage of all 10 vehicles, what you will do is you will pick up, you will arrange a vehicle and then you pick up the middle one. Middle in the sense the fifth vehicle or the sixth vehicle. So to check the mileage, which is nothing but the middle value. Then comes the mode. Mode is the most repeated value. Mode is nothing but most repeated value. Then kurtosis is the measure of peakness. Measure of peak. Then skewness is the measure of flatness. And skewness along one side, that is one-sided skew of normally distributed curve. Maximum is literally represents the maximum value. Say, for example, if the stock value, the highest TCS stock value is 208, within the 10 days, the maximum value is 208. The minimum I traded at 192, then 192 is the minimum value. Range is nothing but max equal to maximum minus minimum. So this is what together is called as a descriptive statistics. So descriptive statistics literally describes how the data are acting. Okay, now let us perform the descriptive statistics. Well, first of all, let me show you the data set map. So this is the questionnaire. So this is a questionnaire to identify the training need analysis in software industry. So this is a real data and real questionnaire. So this is related to how far a training need analysis is carried out in a software industry. So the objectives was to study and understand. As I stated, you see the flow to study and understand the concept of training need analysis in context with IT industry. You see the second objective to identify the important performance gap within the software industry in Chennai. To conduct an organizational task personal analysis, you see analysis within the software industry in Chennai district, and to perform to analyze the performance discrepancies within the software industry to estimate the impact, which is the research gap. If you take a close look for each and every objective, there will be a questionnaire set. You see, first is a demographic that by default. And you see the second section will be related to organizational task and personal level analysis. You see the questionnaire, you will be having, you see, assessment of training needs, which is the second objective. Yeah. Followed by, you see the performance gap. Sorry. Yeah. Here itself, you will be having all the aspects. Performance gap, which is your third objective, the performance discrepancies. Fourth objective, sorry. Similarly, the organizational analysis, you see organization analysis, task and job analysis, person analysis, you see, this is our third objective. For each and every objective, we have a part in a questionnaire so that everything is fulfilled. Say with respect to performance gap, we have the following questions. Performance gap is a factor and every variables. For example, adequate training and resources are employed is the variable. This is been converted into a question. The company provides adequate training and resources. The second variable is related to performance area, feedback, whether regular feedback is given or not. That is our second variable. That is also been converted into question. The organization provides regular feedback. Similarly, for your own research, whether it is in education or whether it's in social science or with as the business research, what I am illustrating right now, everything for there should be a factor and for the variables need to be converted into a questionnaire. And most important aspect is that for every objectives what you have stated, there should be an there should be an section in a questionnaire, so that even the reviewer may able to easily identify that each and every objectives are fulfilled in the questionnaire, which means analysis is performed and it's been interpreted and findings has been illustrated. So these are the important things. So now let us perform now let me first illustrate how to do a percentage analysis. That's a very beginning, because talking about statistics, which literally illustrates about descriptive and the inferential statistics, let us start with the very basic fundamental percentage analysis. In order to do percentage analysis in SPSS, what you have to do is that you have to feed all the data into SPSS. How to feed all the data into SPSS? So let me open and tell you. You see, this is how the SPSS will be completely plain. Completely plain. Say, for example, what is your first question? What is your first question? The demographic question. Our first question is gender. The second question is age. So how to type that? in the label column, you have to type the question, that is gender, age. So in the label column, you have to type the questions and the options. If you take a close look, for gender, we have the options like male and female. And for age, we have following options: 20 to 25, 26 to 35. So how to feed these options? To feed these options, we have to go to values. Values in the sense, what is our first option for in the gender? First option is male. We have to type it as male. The second option is female. I'm going to click OK. So now our first question has been entered and its corresponding option has been entered. The third important thing what you have to do is that you have to select the, you have to select the measures type. Measure in the sense, despite the statistics have two types of data, that is categorical metric, the SPSS will show you three types of data. The scale, which is completely numeric. You see the scale symbol here, ordinal. Ordinal is nothing but a Likert scale based question. You see step by step, that is strongly disagree, disagree, neither agree nor disagree, agree, strongly agree. You see there is a step by step improvement. That is what is called as ordinal scale. Nominal scale is nothing but a categorical data. So what is a categorical data? Just like this, male and female. You see, there are three circles. If you take a close look, you will see that three circles are not touching each other. So this gender is a nominal data. I'm going to click nominal data. Similarly, age. If you take a close look, the age category is 20 to 25, 26 to 35, like that is going. So the first option is 20 to 25. Second option is 26 to 35. The third option is 36 to 45. And the fourth option is 46 to 55. And fifth option is above 55. Now, someone tell me, is this a metric data or a categorical data? Someone please tell me. Anyone?
Categorical.
Categorical. Very good. How do you say it's a categorical data, ma?
Sir, because it has been categorized into different age groups.
Very good, ma. Very good. Very good. Keep it up, Deepika. So it's like if we ask age and we simply, if we simply put question like age and dash, it could be any number. At that point of time, it becomes a metric data. Now we have categorized. Despite the option or numerical, it has been categorized. Whether you belong to 20 to 25 or 26 to 35 or 36 to 45 or 40, now it's been categorized. So it's a categorical data. Very good, Deepa. So it is nominal data. Now, how to feed the other questions? Say, for example, Likert scale based questions. Just copy paste. That is more than enough. Say, for example, let's copy paste these questions. Drivers for conducting the training. Just copy, paste it in the label session and the options. Options like first is strongly disagree. Write it fully, ma, because since we have very limited time, within 1 hour, I need to cover lots and lots of things. So that's why I'm running fast. In case if I'm going too much fast, please let me know so that I may slow down a little bit. Okay. 2 is disagree. Write fully, ma. For time being, I'm writing like this. Neither agree nor disagree. Fourth is agree. Sorry. Yeah. And fifth is strongly agree. I'm going to click OK. Sorry. Fifth is strongly agree. Similarly, if you wanted to copy paste this option to all these things, if you take a close look, all these options have the same, all these questions has the same option, strongly agree to strongly disagree. So I'm going to just copy, right click and copy and paste this. You will be getting it. These are Likert scale based question. Likert scale based question comes under ordinal scale. You can also choose scale if your population size is more than 385. No problem. There is no thing at all. As I stated before, if metric data means it could be both number or a Likert scale, provided the sample size should be greater than 385. Similarly, let me close this. I have entered all the questionnaire into this particular data set. So now you have understood how to feed the questionnaire into the SPSS. So now comes the data sets. If you take a close look, yeah, you see, these all are our questions. You see, these are the data sets. I tell you what this data set represents. I told you, right? All the applications, irrespective of the many things like PSPP, SPSS, AMOS, EViews, Stata, Systat, MATLAB, everything knows only numbers. They don't understand any statements or alphabets or strings or anything else. So in order to feed the data into a SPSS, once again, you have to convert all your options into numbers. Say, for example, D1. D1 is nothing but demographic question 1. Here, the most important thing we have discussed how to feed the question, how to feed the options, and how to select the measure. And it is also advisable to put the name. I'm telling you why to put the name here as D1 or D2, D3, because here, if you take a close look, demographic question, there are 6 demographic questions. You see, 6 demographic questions. 6 demographic questions. So that I have marked that as D1, D2, D3, D4, D5, D6. Because here, if you take at a data view, everything, the top, you see D1, D2, D3, for easy recognition, you have to put it like that. And I have copy pasted these data set. I have converted all my data into the following things. Say, for example, if you take a close look here, 1 represents male. If you see, almost 16 respondents, almost 6 respondents are male and 7th respondent is female. Similarly, the 11th respondent is female. This is what is been stated here. I have given the question. After collecting the data, you will be having the questionnaire with the selected options. All these will be put into Excel sheet in the terms of number. You won't be putting the option. You won't be writing the option. You will be simply writing the numbers in the Excel sheet. Say, for example, if we selected the first option, you have to type the 1. If we selected the second option, female, you have to type it 2. Similarly, for all the things, the respondent for the 7th respondent is female, and the second option, the 4th option is nothing but he belongs to age category above 55 years. No, yeah, 46 to 55 years. And D3, what is the demographic variable 3? She is married, 1. So similarly, it goes on. All the things is been fed into the Excel sheet in the form of number. So once it has been fed up, put in the terms of number, then those numbers, these data set has to be copied to the SPSS data view. This has to be copied to the data view. You see, so in the variable view, you will be typing all the questions. And in the variable view, you will type in the label column. You will be typing all the questions. The value, you will be typing all the options, and you will be typing. You will be selecting the measures, and finally, you will be giving the name. And in the Excel sheet, after completing all the data set in terms of number, you will be copy pasting it simply. So now we will be performing a percentage analysis. Let us perform percentage analysis for this demographic question. So how to perform a percentage analysis? In order to do a percentage analysis, click on Analyze, go to Descriptive Statistics, click on Frequencies. So to do percentage analysis, click on Analyze, Descriptive Statistics, Frequencies. Select the questions for which you need to do the percentage analysis. I wanted to do for all demographic questions. What are the demographic 6 questions? So in order to know the exact, you see, after labeling at D1, D2, D3, D4, D5, and D6, it's easy for me to identify. You simply right click as display as variable labels. It will be illustrating the question labels. Or if you wanted to display as names, right click, display as names, everything will be displayed as names. Now let me select 6 demographic question and then click OK. By just click of the button, you will be getting the percentage analysis. You no need to do any coding or anything like that. You see, majority of the respondents in IT industry are male, 122 are female, 73.6% are male, 26.4% are female. And majority of the IT employees working in Chennai districts are belonging to the age category between 20 to 25 and 26 to 35 years. Whose percentage is 31.6 and 40 percentage. Similarly, most of them are unmarried. They all belong to UG as a qualification, followed by PG. And they also earn income between 26 to 35, followed by 36 to 45. So this is what is the study. So you see, by the click of the button, you got the percentage analysis. Now let me explain you how to do the descriptive statistics. You hope you are remembering what I stated right now. Descriptive statistics is nothing but mean, median, mode, kurtosis, skewness, maximum, minimum, and range. So what is mean? Mean is an average value. Median is the middle value. Mode is the most repeated value. Kurtosis, kurtosis spelling wrong. Kurtosis is a measure of peakness. Skewness is a measure of flatness, skewed on one side, whether left or right side, maximum value, minimum value, and range. So let us perform for some questions. Say, someone suggest me a question. Yeah. What for their training is done? Is it for career opportunity or timely completion of the project or change environment or growth organization? Let us take this question alone. Career opportunity, AA1. Or let us consider all these aspects, all 4 aspects. So in order to do descriptive statistics, go to descriptive statistics, click on the descriptives. Once you click the descriptives, it will be asking you what questions has to be considered. So I'm going to consider career 1. See, for that question is, I think that one question is more than enough as of now. Sorry. So if you click OK, you will be getting only following things: minimum value, maximum value, mean. But in case if you want more things like mode and other things, click on the options. Click on range instead of, yeah, sorry. Go to descriptive statistics, click on frequencies once again. In the frequencies, select the questions. Select the question for which you need to do the descriptive statistics. Say, for example, for this one, once the question has been selected, click on the statistics. The statistics, it will be asking you what you want. I want mean, I want median, I want mode, I want the measure of skewness, I want the measure of kurtosis, I want maximum value, mean value, range. Standard deviation, variance is nothing but how far it's deviating from the mean value. I also want standard deviation. Variance I don't want because it's a square of standard deviation is variance. So I don't want that. Let me click OK. And then click OK once again. You see, now we got the output. So we could clearly say that majority on an average value is 4.279, which means majority have strongly agree. Out of 462 respondents, majority have either agreed or strongly agree. You see, 197 to 11. Only few, 36, 8, 10 have selected disagree, strongly disagree, which means 4.279 is the average value out of 5 options. What are the 5 options? Strongly agree, agree, neither agree nor disagree is the third option. Now, fourth option is disagree, and fifth option is strongly disagree. So 4.27 is close to the 4.27 is close to fourth and fifth option. Agree and strongly agree. That is what is 4.27. Median is nothing but the middle value, which means among 462, the middle value is 231. The 231 respondent have chosen the 4 as an option. That is what is median value. Mode I said as most repeated value. What is most repeated value? Most repeated value in the sense, if you take a close look, strongly agrees 211. Agree is 197. The most repeated value is fifth option. That is what is being stated here. Mode. Mode is the most repeated value. Fifth option. Standard deviation is how far a value is getting deviated from the mean value, the 4 point. It is either getting deviated by only 0.84 value. That's great. So skewness and kurtosis are generally used in stocks to measure the flatness and the peakness, generally not used in these kinds of data set. So if the value of kurtosis is greater than 3, which means the peakness is high. If the skewness value is that is -3 to +3. Some says -1 to +1. It depends. Both are acceptable. And similarly, skewness also should be either -1 to +1 or -3 to +3. It depends upon the data set. And maximum value, we see the maximum value is fifth as an option, 5. And strong minimum value is 1, that is strongly disagree. So 1 to 5. Range is nothing but 5 minus 1, 4. So this is what is a descriptive statistics is all about. Descriptive statistics says that on an average, majority of the respondent have either agreed or strongly disagreed. Sorry, I either agreed or strongly agree that they do training for career opportunity. And majority of the respondent have said that they are getting training for career opportunity. Fifth as an option, strongly agree. And most of the answer is only deviating by only 0.8. That is 0.8 in the sense it is 4.2 plus 0.8 or 4.2 minus 0.8. That is how it has been deviating. Answer is deviating very little bit, which means majority of the respondent are doing training for career opportunity. So this is what is the descriptive analytics says. So is this very clear, ma? Is this clear, ma? Now let's go on to the significant association test. So in order to do significant association test, what are the important thing? What is the important aspect? Two data has to be categorical in nature. The two data has to be categorical in nature. Let us consider two categorical data. Say for example, yeah, are you aware of your organizational training need assessment? Yeah. First, whether how frequently training programs are organized. So how frequently training programs are organized with respect to gender. Let us see. Whether males are given more training program or females are given more training program. Let us see. Or can we see with respect to, yeah, let us see with that. See, if you take a close look, this is also a categorical data. Sorry. This is also a categorical data. And similarly, gender is also a categorical data. So now let us perform a chi-square test. That is to find out significant association between the variable or not. So in order to do the chi-square test, go to descriptive statistics, click on the cross tab. In the cross tab, what you have to do is that you have to select both the variables under rows and columns. That is gender in row, and let me select this one in a column. Now I'm in the statistics tab. Click on the statistics tab. Click on chi-square statistics and click on phi and Kramer's value. This is a best statistical measure to illustrate whether there is significant association or not. And in the cells, click on expected value. And then if you want chart, click on display the clustered bar chart and click OK. Now we will be getting the output. It may take some time. Yeah. You see, now we got the output. How to interpret the output? To interpret the output, we need to look at the significance value. If the significance value is less than 0.05, let me repeat, if the significance value is less than 0.05, then we have to reject the null hypothesis. That is, there is significant association between the two variables. If the significance value is greater than 0.05, we have to accept the null hypothesis. What is a null hypothesis? There is no significant association between the two variables. If you take a close look here the Pearson chi-square significance value is 0.000, which is less than 0.05, which means there is significant association between the frequency of training and the gender. Let us take a close look. If we take a close look, males are frequently given or sometimes or frequently given training, whereas females are also sometimes or frequently or always given training. So which means irrespective of the gender, they are given training frequently or sometimes or always. So there is some association. You see, for male also these three things is high. For female also these three things is high. But for female, even these two things are a little bit there. But still, this is what it said. There is significant association between the two variables. You see, this is how we have to interpret this is how we have to do the chi-square test using SPSS to find out whether there is significant association between the variables or not. Okay, so now we have done the very first thing, that is there is significant there is two categorical data. If there is two categorical data, then we need to do significant association test using chi-square test or correspondence analysis. So now we have understood how to perform the significant association test. Now let us move on to the correlation analysis. Let us consider two data that is metric in nature. Let us consider two data that is metric in nature. Say, let us look at the questionnaire. Yeah. If you take a close look, this training provided performance gap, organizational analysis, task and job analysis, and personal analysis. You may ask a question, sir, these are the factors and it has many variables. How you converted those into a question? How you converted those into a data set? That can be done using SPSS. You can transform the data set. That, if possible, I will be teaching you in the SPSS session. In order to transform the data set, you need to make use of this tab. What you do is that, say for example, there is a first thing is performance gap. If you wanted to do performance gap, performance gap is nothing but average value of all these questions. So it has nearly 11 questions. You see, all these 11 questions in the questionnaire, you see, yeah. You see, this 11 questions is being added and divided by 11. The average value is being put up here. The transformed data set is being put up here as a performance gap. Yeah, PG. You see, that is what. So this we can do using transformation tab. So now we have performance gap, organization analysis. I wanted to know whether all these variables, all my variables have also a relationship with one another or not. In order to do correlation analysis, what you have to do is that you need to click analyze, you need to click correlate, you need to click bicorrelate, bivariate analysis, select the variables. What are the variables? What are the variables? That is performance gap BG, that is organization analysis, job analysis, personal analysis, performance discrepancy analysis, and training need analysis. For whatever variables you wanted to perform correlation test, select all the variables or just two variables, anything. It's for, then click on Pearson. Pearson is the best way to deal with scale data, that is metric data. If in case, if it is a categorical data, that there is a separate scenario for which you will be using Spearman correlation that I will be teaching you in the SPSS session. So click on OK. Now you see we got the output. Oh, this is fascinating. Even I have not seen this output before. Okay, so you see there is a significant relationship between all variables. You see, I told you, right? If the significance value is less than 0.05, the null hypothesis is rejected. What is a null hypothesis here? The null hypothesis is there is no significant relationship. There is no significant relationship between the variable. But if you take a close look here, everything is less than 0.05, which means we need to reject the null hypothesis. On rejecting the null hypothesis means there is significant relationship between all the relationship between the variables. There is significant relationship between the performance gap and organization analysis. There is a significant relationship between performance gap and job analysis. Significant relationship between performance gap and performance assessment, some like that. Performance discrepancy analysis, sorry, personal analysis. And PDA is performance discrepancy analysis, training. There is significant relationship. You see, all the significance value is less than 0.000. So in order to know how much of relationship there it is there, you need to look at the Pearson correlation value. If the Pearson correlation value is 0.816, it represents there is 81.6% relationship between the variable. That is, there is 81.6% relationship between the performance gap and the organization analysis. There is 79.8% relationship between the performance gap and the job assessment. So this is how you have to do the correlation analysis. So in order to do correlation analysis, what you have to do? You have to click analyze. You need to go to correlate. Click on the bivariate, select the variables for which you need to do the correlation analysis, and then click OK. So this is how you have to do the correlation analysis. So similarly, if there is correlation analysis, as I stated before, where it is, yeah. If there is correlation, then you can go for regression test. So how far one variable is influenced by many variable. Here the performance gap is the important variable. Sorry, training need assessment is the important variable. Other things are dependent variable. Sorry, other things are independent variable. Training need assessment is the a dependent variable, because you need to assess the training need using the performance gap, using the organization analysis, using the job analysis, personal analysis, performance discrepancy analysis. The training need assessment analysis required all these aspects. So let us perform regression. So in order to do regression, what you have to do is that you need to click analyze, go to regression. As I stated before, there are different types of regression that you can perform using SPSS. As of now, I'm going to teach you only the linear regression. Okay, using the curve estimate, you see there are various regression techniques that is available: quadratic, compound, growth, logarithmical, cubic, sine, exponential, inverse power. But I'm going to teach you only linear. To do linear regression, click on analyze, go to regression, click on linear regression. Select the dependent variable. What's the dependent variable here? Training need analysis. And what are the other independent variables here? Performance gap, organization, all these comes under independent variable. Now I'm going to click OK. This is called as multiple regression. In case if you are going to consider only two variables, one is a dependent variable, one as an independent variable, it is called as simple linear regression. If there are many variables, it's a multiple linear regression. As simple as this, mark. Click on OK, you will be getting the output within a fraction of a second. Once again, this values are great. Oh, super. Okay. So what is this regression? Regression say for regression analysis, you have to look at the following aspect. You need to look at the R value, R square value, ANOVA significance value, and finally all the coefficients value. So coefficient significance value. So what is this R value? R value is nothing but the correlation value, that is 0.909, which means the training need analysis and other variables, other factors we have considered, that is performance gap, organization analysis, job analysis, person analysis, performance discrepancy analysis, all have 0.909 relationship with the training need analysis. And the training need analysis can be forecasted with 82.7%. That is 0.827 is the R square value represents the forecasting accuracy. The regression value tell you how to forecast the values. So this I will be explaining you if time permits. So the then the ANOVA significance value should be less than 0.05. Then only your model is fit. If your R value should be greater than R square value should be greater than 0.6. ANOVA significance value should be less than 0.05. And if most of your coefficient value is less than 0.05, then only your regression equation is fit for consideration. Now our regression equation is fit for consideration, which means training need analysis can be forecasted using performance discrepancy analysis, personal analysis, job analysis, organization analysis, and performance gap. Sorry. Here the coefficient, performance analysis coefficient is greater than 0.05, that is 173, which means the training need analysis is influenced by performance gap, organization analysis, job analysis, and performance discrepancy analysis. It is not influenced by the personal analysis. So this is how you have to interpret the regression analysis. So now you have understood how to do the correlation analysis and regression analysis. So in order to do the regression analysis, what you have to do, you need to click the Analyze tab, go to Regression, click on the linear regression, select the dependent variable and independent variable, click on OK, you will be getting the output. In order to interpret the output, what you have to do, you have to look at the R square value. It should be greater than 0.6. ANOVA significance value should be greater than less than 0.05, and all your coefficients should be less than 0.05. So what is a regression equation to forecast? That might be your question. So regression equation is simply for linear regression. There are different regression equation. For exponential, it is a different equation. For quadratic, it's a different equation. For linear, the regression equation is given by y equal to a plus bx. A is nothing but the constant value here, that is 0.037. That's our constant. Bx is nothing but B is nothing but 0.221 into performance gap plus 0.216 into organization analysis plus 0.212 into job analysis plus 0.292 into performance discrepancy analysis. So if you have value for all this, you may able to judge the training need assessment. This is primary data. It may not sound little bit logical, but it is statistically logical. And the most important thing is that if it's a secondary data, it may be very much suitable for this kind of regression analysis, will be very much suitable for forecasting the things, because you will be having numbers for everything. So I have also taught you the influence test. Now the last thing is the different types of t-test. So let me perform only independent sample t-test and ANOVA test. I think there is no much time. So there are criteria for test. For example, independent sample t-test, you can do only with the data which is having only two options, two categorical options. You see, male and female, it has only two options. For this only, this and one metric data, say for one metric data is career, let us consider the career opportunity itself. So if one data is categorical and another data is metric, we can go for we should go for significance difference test. You see, if one data is categorical and another data is metric. If one is having only two options, then you need to do the independent sample t-test. If there is 2+ option, you need to go for ANOVA test. So let us perform independent sample t-test. In order to perform sample t-test, go to compare mean. Click on independent sample t-test. So what is the categorical data? I'm going to select gender. And what is a going to select, that is career opportunity. If you take a close look, it is asking question. What is the question? The question is, excuse me. The question is, what are the two groups? Even you have 4 or 5 groups, the independent sample t-test, as I stated before, it will be selecting only 2 groups. That is, group 1 is male. You to select only 2 groups. What are the 2 groups? So that is what is independent sample t-test. If there is only 2 options, you need to go for independent sample t-test. Click on continue, click OK. Now you got the output. You see, for male, the mean value is 4.3. And for female, the value is 3.9, which means almost equal to 4. This also equal to 4, which means there is, we can say there is significant difference. There is significant difference. You see, by the value of 0.4, which is a great value. So we can say that, let us look at the significance value. Yeah, you see the significance value. The significance value, you need to look at the significance. There will be 3 significance value in independent sample t-test. As I stated before, if the significance value is less than 0.05, null hypothesis is rejected, which means the straight significance value, this one is rejected. So the next significance value has to be considered. So this is 0.000, which is also less than 0.05, which means the null hypothesis is rejected, which means there is significant difference in the mean score between male and female, which means for the training needs, the career opportunity with respect to male and female is seen in a different way. For male, they are seeing the career, mostly they are looking forward for career opportunity. For female, they are not looking forward for career opportunity. Mostly they are looking for career opportunity, but apart from that, they are also looking for some other aspect. That is what is the inference. So there is a significant difference in mean score. You see, it's 3.9, it's 4.3. It is almost close to 4.5, and this is only close to 4. That's why there is significant difference in opinion for career opportunity between male and female. If there are 2+ options, you need to go for ANOVA. So let us consider the data set. Let us do for age and career opportunity. Once again, compare mean, click on ANOVA, one-way ANOVA. Select the age as a factor. Here it will not be asking the 2 groups. Since there are any option, 2+ option, you can go for ANOVA. Career opportunity as the dependent, click on OK, you will be getting the output. You see, we got the output. Once again, you see there is significant difference in opinion with respect to different age group. You see, there is the null hypothesis is there is no significant difference in opinion for career opportunity with respect to different age group. But here the significance value is less than 0.05, which means it says that there is significant difference. The null hypothesis is rejected, which means there is significant difference in opinion among the different respondents belonging to different age category. So this is how you have to do the significance difference test. I think we have completed all the important aspects of the SPSS. Apart from that, SPSS has few tests like factor analysis and the cluster analysis and other things that we'll be discussing if possible in a separate session of SPSS. So is everything clear as of now? So can we have a discussion session? Oh, okay. Rose have stated how to, yeah, I will tell you, how to do a ANOVA test. So how to interpret an ANOVA test. Rose, could you give an example of your own study? Could you tell your research title,
Sir, my research title is Influence of Cognitive Ability and Behavioral Problem on Academic Achievement of Higher Secondary School Students.
Okay, So Rose, listen to me very carefully, So consider this one as a cognitive ability. Cognitive ability, say for example, timely completion of project. You see, the timely completion of project, consider this particular question as a cognitive ability, Okay?
Okay.
And consider this question. Consider this question, age as a age group, that is between, you are saying higher secondary education, right? So what
Yes,
will be their age group? Either it will be 11 or 12 or something like that, right? How much?
17 and 18.
17 and 18. Oh, 17 and 18. Okay, consider 16, 17, 18 and
Okay.
15,
Okay,
16
sir.
and 17, ma. Okay.
Okay, sir.
So the age is 15, 16, and 17, and this timely completion as cognitive ability. So
Cognitive
what
ability.
your hypothesis will be? The hypothesis will be there is no significant difference in the cognitive ability among the students belonging to different age groups. This will be your hypothesis, right?
Yes.
So if this is an hypothesis, how to do an ANOVA test? Click on analyze, go to compare mean, click on one-way ANOVA, select the variables, say instead of this, timely completion and age group, and click OK. If you want, say for example, if you want statistics, you can also click descriptive, click OK. If you take a close look, how to interpret when it comes to SPSS, everything is this significance value, ma. For example, Rose, listen to me very carefully, ma. The thing is that if you are a judge, okay, if you are a judge, I am a lawyer. You are telling me, as a judge, I will be accepting your case only if you bring me at least 5% evidence. What is 5%? 5% is 0.05, right?
Yes, sir.
So if I'm not bringing, I'm bringing 0% evidence, what you will do? You will be rejecting my case, right?
Yes, sir.
So here, if you take a close look, the value is less than 0.05, it's 0.000. With 0% evidence, if I come to you as a lawyer and ask you, accept my case, will you accept me? No,
No,
you
sir.
will be rejecting my case. So I'm nothing but the null hypothesis. So null hypothesis is what? Null hypothesis states there is no significant relationship. There is no significant association. There is no significant difference. So which means you have rejected me. So what you will accept? There is significant difference in the cognitive ability among the students belonging to different age group. So this is how you have to interpret the ANOVA. You see the mean score is different across almost most of the age group. It's 4.4 and 4.4 for both is okay. If you look at this, it's 3.9. If you look at this, it's 4. It's 3.6. Similarly, it goes on. It's not constant across all age group. So which we can conglomeratively say that there is significant difference in cognitive ability. Do you got the concept, ma? Is everything clear for you?
Yes, sir. Very clear. Thank you so much, sir.
Okay, ma. So anyone, any other doubts, ma?
Sir, excuse me.
Yeah.
Sir, I have a very silly doubt.
Yeah.
Sir, actually, I'm planning to do a research paper on self-help groups and fintech,
Great, ma.
fintech.
Great.
So, sir, then what would be the hypothesis we can set for this particular topic?
This is very, very broad term. You are going to do a study research article based on self-help group and fintech. So
Yes.
with respect to fintech, you will be having various factor. With respect to self-help group, you will be having a various factor. So hypotheses are linked one another based on factors and variables considered, based on the demographics and based on the factor what you are going to consider. So I cannot blindly say what could be the hypothesis. So I hope if you take a close look at Rose, what she asked cognitive ability is one of her factor. Now demographic quotient as another important factor. So now with one as a categorical data, another as a metric data, I have combined and stated the hypothesis. Similarly, under fintech, you will be having various factors. You have to consider that factor with a demographic or its own fintech oriented factor to say the hypothesis. We cannot blindly say what will be the hypothesis for the entire. You cannot say one hypothesis for your entire article. For even an article, there will be a multiple hypothesis, say 2 to 3 hypotheses based on your factors and the demographic questions what you are going to consider. So, what I suggest is you go through the articles and find out the factors, and based on the factors, you consider it, ma. For example, if there are multiple factors, so all things will be in the metric data, right? So you tell that is you have to formulate in such a way there is significant relationship between the two variables or not, significant association between two variables or not. That's how you have to formulate the hypothesis, ma. This is very broad question. Okay.
Okay, sir. Thank you.
Okay. Anyone, any other questions, ma? Is everything clear? Have you understood the essence of statistics? So statistics is very simple, ma.
Sir,
Yeah.
sir, sir, actually, I am very basic, sir.
Mama,
I don't know
just hold on a
about
minute. Your
all
voice is
this
cracking too much, ma.
statistics, sir. Sir, I just want to know whether this SPS. Hello, sir.
Yeah, I could hear it, ma. I could hear you. Please.
Uh,
Go ahead.
Sir, I am new to statistics, sir. It's very new every topic, sir. I want to know whether this SPSS ANOVA all is it a software, sir, or it should be done by ourselves, sir, for our research study.
I suggest using these softwares, ma. I don't use to go with manual method because in realistically, if you do ANOVA analysis considering various variables, you have to use a log table, and the most important thing is that human errors are very much possible. And these software has a prescribed algorithms and updated algorithms related to ANOVA and all the statistical tools. So, which means the precision will be more high than what you do. And most important thing is that the statistics may be sometimes get updated, ma. So at that point of time, the softwares and its upgrade also gets updated, which means you have an added advantage of not using the old algorithms. So always use an application. It is because nowadays nobody does ANOVA or independent sample t-test or paired sample t-test or correlation by using manual method. It doesn't works out well. Okay, so it is always better to use a software, ma. Okay, there are various software. Even you try PSPP, that is open source free version software, very similar to SPSS. Okay, you try that, ma.
Okay, sir. Okay, thank you so much, sir.
No issues. Okay. Any other question, ma? So is this session very clear?
Sir, can I ask one more doubt, sir?
Yeah, please, ma.
Sir, is it compulsory to go for regression analysis after correlation, after finding the
No,
correlation?
no, absolutely not. Because here we have got a good regression analysis. I tell you, most often I see that regression analysis not getting satisfied in many aspects. As I stated before, is my screen visible? Is my screen visible?
Yes, sir. Yes.
Okay. Sometimes you will be getting the good R square value of greater than 0.6, but you won't be getting the ANOVA significance value. Sometimes you will be getting all these three values getting satisfied. There is good R value, good R square value that is greater than 0.6, ANOVA significance value less than 0.05, but you will notice that coefficient or greater than 0.05. So most often this regression equation does not fit in most of the cases because forecasting is something unique what you can do or give or contribute to your research that won't get satisfied simply. So most often it will be satisfying the correlation test and regression test. It won't be getting satisfied at that point of time. Don't show the regression analysis. Stop with the correlation analysis. That's more than enough. And it is not necessary after doing the correlation analysis. If there is a significant correlation, you need to do the regression analysis. If you want, you can do it if it sounds logical for your research. If it doesn't sound logical for your research, it is better to avoid the regression analysis. You got it, ma?
Okay, sir. Thank you. Thank you, sir.
Okay, ma. So, can we wind up the session? And please don't mistake me. Sorry for the delay. There was a medical emergency. I hope you all understood.
Yes, sir.
Okay. So, okay then. Thank you all. Thank you, God. We see. Take care. Bye. If possible, we will see in the next session of SPSS on our other things like that.
Contact RCHUB International Foundation for Research and Education. WhatsApp 9888 231 231.